Cito 3, there we are. Today joined by Nick White, who is the co-founder over at Celestia. And yeah, this is the first time actually that you're on the show, but you have also been a big supporter at what we've been doing at Cosmoverse. It's been cool to meet you there as well. So yeah, it's exciting to have you on today. How is everything going on your side?
Hey, really great to be here, Cryptocito. Thank you for the introduction. I'm Nick White, COO of Celestia Labs. And I just want to give a shout out to you and your whole crew for organizing Cosmoverse and being such a critical pillar to the Cosmos ecosystem. I can't believe how far things have come and grown since the first Cosmoverse in Lisbon, which was just blew everyone out of the water. And then you topped it once again in Medellin. And for people who were not there, the energy was just insane. Like the quality of presentations, the quality of all the different builders, and the excitement for the Cosmos ecosystem broadly was just off the charts. And not only was it very useful and informational, but also was an extreme amount of fun. Like, you guys know how to get everyone out and throw a good party. And it was just something that I think everyone there will remember for the rest of their lives. But a lot of people were telling me, for example, that the Cosmos ecosystem at Cosmoverse felt like Ethereum back in 2016. And I wasn't there so I can't necessarily corroborate that, but it felt there was magic. And if anyone is out there wondering if they should attend Cosmoverse next year, the answer is yes, hands down. Best conference of the year for me.
I really appreciate that, man. Yeah. Thanks for the kind words. And it's awesome to also have your guys' support for the second year in a row now, basically since Cosmoverse Genesis. So yeah, looking forward to the next years. Yeah, hopefully also Cosmos as an ecosystem will gain more awareness. So that's the whole point of these events. But yeah, really, really appreciate that. But yeah, maybe since it's the first time that you're on the channel, you can share a little bit on your personal Cosmos journey and crypto journey, and what eventually led you to co-found Celestia.
Sure. So I got interested in blockchains and cryptocurrencies in late 2016 because a lot of my friends were talking about Ethereum, no idea what it meant. I kind of slowly slid down the rabbit hole throughout full jump in 2018 when I co-founded this project called Harmony. And really my thesis from that stage was that we needed to solve scalability of blockchains, because although there were a lot of cool use cases coming up, until we solved that, it wasn't the total. You wouldn't be able to actually make any of these use cases practical. And so at Harmony, we were trying to solve that doing sharding and proof-of-stake. And I was there until late 2020 when I learned about a new approach to scaling that we now call modular blockchains. And it immediately just kind of jumped out at me as something that was going to revolutionize blockchain infrastructure and architecture. So, I got so passionate about it, I couldn't sleep, basically. And so for 2 weeks, I was just researching and learning everything I could until I realized yeah, okay, for sure, this is the future. And that is actually now shifting gears to Cosmos and how I got introduced to Cosmos. I learned about Cosmos, I would say in 2018, just from doing research in the space. And at that time, no one was talking about interoperability. No one was talking about bridging and the fact that there's going to be multiple blockchains. And this whole idea of the Internet of Blockchains seems so foreign, and that just goes to show how far ahead of their time they were. And the other thing about Cosmos was that they were the people that kind of popularized the sort of BFT consensus style mechanisms that now are used basically across, unanimous across most proof-of-stake blockchains. And Harmony, we also adopted a similar sort of BFT thing. We didn't use Tendermint. We were one of the few projects that didn't fork Tendermint, like Polygon and Binance and others. But we were still kind of inspired by that because we knew that it was a really good idea. So I would say Cosmos, the impact of Cosmos, even if it's not visible, is everywhere because of just the thought leadership and the vision behind it that end up shaping a lot of the things that have been built today and used today.
I think that's also a good starting point for maybe those that have never heard of these terms, monolithic or modular blockchains. So maybe you can explain that. And I always love to give analogies that might be easier for understand for the crypto community. With this thought in mind that Bitcoin is the internet of money, Ethereum is the world's computer, kind of like narrative or analogy. What is Celestia in that context? And maybe you can explain the term modular blockchains.
Yeah, well, I like to think of Celestia as the internet of modular blockchains in combination with Cosmos. And what that means is that, first let's talk about modular blockchains. So modular blockchains are a new approach to blockchain architectures where, all like blockchains since Bitcoin, Ethereum, Solana, even every Cosmos chain are built in this way where you have a single protocol that does all of the work. So all of the nodes on that network do all of the work associated with running a fully fledged blockchain. And fundamentally, that causes a lot of constraints and trade-offs that you can't really escape in that paradigm. And so what a modular blockchain is it rethinks how to build a blockchain from basic principles. And what you realize is that you can actually separate a lot of the functions of a blockchain into separate layers and separate protocols. And then when you do that, you actually break the box wide open and you get the ability to have much better properties when it comes to scaling, when it comes to flexibility, things that the Cosmos ecosystem really cares about. You get sovereignty, and it becomes very easy actually to deploy new blockchains for the first time and innovate in a way that you couldn't before. So that's what a modular blockchain is. And then the reason I say internet of modular blockchains is because Celestia is very aligned with the Cosmos vision of community computers and the fact that the future is not one blockchain to rule them all. It's not a world computer like Ethereum or Solana where everyone is using the same sort of like virtual machine and every application runs on one mega computer. It's more like sort of the personal computing revolution where everyone has their own computer that they get to personalize, except in the blockchain case, it's more like on a community basis. So, and the point is that you want to be able to connect those computers together in a secure way. And that's kind of where the internet of blockchain vision comes from. So Celestia is just, what we believe is that in order to achieve that internet of blockchains vision completely, we need to actually build those blockchains in a modular way.
Can you maybe give some general examples, and then maybe we can also later get into some of the more practical projects also that are already in the works of what modularity in crypto would enable, and like what specifically can you separate? You just mentioned that kind of like the way you see the future of crypto and maybe even the end game is that you have different technologies that you can combine. So how does that work? And maybe can you give broad examples of what exactly you mean by that?
Yeah. So in terms of separating the functions, there's, I would say, at their core, probably three key functions to separate. So there's consensus, which is ordering of the blocks or the transactions, right? Like everyone needs, when you're building these shared decentralized applications, everyone needs to have an agreement on like what happened when, right? And so that's what consensus does. And then there is another function called data availability, which is that for these chains to be secure, you have to make sure that the data behind them has been published and that anyone can look at it and audit it and see what's happening. If that data is actually not published and someone's actually hiding it, then you can't actually have a transparent, secure system. So data availability is that function. And then the last one is what we call execution, which is basically where the applications live. It's where smart contracts take place. It's where most users will actually interact with, whereas consensus and data availability are sort of like more like infrastructure level. And execution is where you make sure that the rules of the blockchain are being followed. So, I mean, the whole point of a blockchain is that you can establish certain rules that can't be broken. for example, in Bitcoin, I can't just mint myself a bunch of Bitcoin, or I can't send you more Bitcoin than I own. Those are sort of the fundamental rules. And you want to make sure that they're not broken, because if they're broken, then the whole system is not useful. So those are the three main components. And what this would actually look like in practice is, for example, you have a protocol like Celestia that is a consensus and data availability layer. So it handles those base two components. And then you would have what you would call a rollup, which is a type of blockchain that does execution. So it just does verifiable execution, and it actually plugs into a data availability layer like Celestia to secure it and to sort of power the decentralization of it. So, people are probably familiar with a lot of different rollup projects, like whether it's Optimism or Arbitrum or Starkware or zkSync. And there's so many, right? I can't list them all. And there's a lot more that are being built currently, because as this modular revolution kind of grows.
And like from a developer's perspective, what would be the benefits of that? I guess customization is one of them. Probably also efficiency, speed. But what are some of the also like long-term benefits that developers and applications would have if they were to build on or blockchains if they were to be built on Celestia?
Great question. So luckily, I'm assuming a lot of the audience here are familiar with the Cosmos vision and this whole thesis around Appchains, right? So what like Celestia and a modular blockchain stack enables you is you get the benefit of Appchains from sort of the Cosmos model, while also getting the benefits of a world computer model like Ethereum or Solana, in that you have shared security and you have the ability to deploy your application really easily. So to kind of unpack this, you on the Cosmos model, when you have an app chain, right, you get a few different things that are really powerful. One is it's kind of scalable by default, because you end up having your own computer that only runs your application. And so, rather than running your application in a way where you're sharing resources with every other application and competing for gas and competing for sort of space on that computer, you get your own. So you have kind of scalability out of the box. The other super powerful thing you have is customizability. So, imagine if, in the personal computing world, there's lots of different kinds of operating systems, right? Like everyone wants to use a different operating system according to what applications they want to run on their computer. And certain applications just aren't compatible with a certain underlying operating system. And so this is the same in blockchains, in the sense that the virtual machine that blockchain runs dictates a lot of what is possible to be done on that blockchain. And when you have an application-specific chain, like in Cosmos, you can actually build that from scratch and actually determine what that, like the core level operating system is, to enable your use case specifically. So you can do all kinds of things that are just not possible if you're only building smart contracts on a world computer like Ethereum or Solana. Mm-hmm. And then you also get what's called sovereignty, which is that you can fork, and you have like the community itself owns the application and has control over it, which is we think very important, because at the end of the day, blockchains are social coordination tools. And if you end up kind of giving that ability to control, or the community to be sovereign over the application they're using, then you kind of sacrifice one of the core value propositions of blockchains. So that's a high level of some of the benefits.
What's cool is that ever since I think the first time I heard about Celestia was actually from Ismail, actually last Cosmoverse, like just before Cosmoverse, I think sometime October or something like that last year. And Ismail obviously has a strong Cosmos background. He's the CTO of Celestia, if I'm correct. Then there's a bunch of others, you included, that are very Cosmos aware and are really fans also of the ecosystem. So how do you view, and from my perspective, it seems like Celestia is not really trying to like compete directly with Cosmos. It's rather maybe an addition or an extension to Cosmos. Same for Ethereum probably. So how do you view the end game for Cosmos, and how does Celestia fit into that? And maybe if you also have some comments on Ethereum. I don't know if you guys are very up to date and following everything that's happening in the Ethereum world with also their rollup roadmap. I guess you might be up to date there. So how do you view the end games for both Cosmos and Ethereum, and how does Celestia fit into that?
Again, great question. So I think it's worth going back to sort of the vision of Cosmos, which is this internet of blockchains, that you want to make it so that anyone can build their own blockchain, any community can spin up their own community computer, and you also want to make it so that they can connect those blockchains together in a secure way, so that they're not just isolated, right? If those blockchains are living on their own, that's not very useful in the long term. So you want all these blockchains to be able to talk to each other, and that's an extremely powerful vision. And I think that is the end game for Web3 is that kind of architecture, and Cosmos has done a ton to get there. Obviously, inventing Tendermint, which is probably the de facto most secure sort of like consensus software, as well as the Cosmos SDK, which helps you build your own app chain, and also IBC and interchain standards that make it so that you can actually connect those chains together. So Cosmos has gone from 0 to 1 on that vision, right? Now we have like over 50 chains if you go to what is it called?
Map of zones. Map of zones.
Yeah, map of zones. Yeah, you're going to see 50 chains. And you're going to see all the connections. You're going to see all this value flowing between those chains, and like it's working and it's real and it's growing exponentially. Like, and people who are at Cosmoverse would have observed that and seen that. It's like an open secret, but somehow like people are not really aware of how amazing the ecosystem is right now. However, all of that is great, and the amount of achievement that has, on an engineering level and everything is just like unbelievable. It is one of the most important things I think that's happened in the space since Ethereum itself. But the long term, right, is like, and I think of this in terms of like the original internet. If you look at the evolution of the internet, it started out as kind of like, just people at home hacking away. They might run their own server, and it's all for nerds and very small scale, right? Then at a certain point, there were only like 50 servers on the internet. But no one could have predicted the exponential growth of the internet. And now you literally hundreds of millions of websites and billions of users on the internet, right? And I think that Web3 is going to go the same way. And so I think of, like, when you look at map of zones today, it's very much like ARPANET back in the day, where it's like, just a handful of blockchains, but where we're going is we're going to have millions of blockchains in the future. And so, and this is the core problem, is that there are some sort of features that are lacking in the current Cosmos architecture that we need to achieve in order to get to that end game vision where there's millions of blockchains. And the two main ones are basically that, first of all, it's still actually quite expensive and difficult to deploy your own blockchain. And that's because you actually, even though Cosmos gives you all the software, you have to build your own consensus network from scratch. So you have to get a bunch of validators, you have to issue a proof-of-stake token, and that's the only way to actually launch a new blockchain today. The other problem is that you don't get shared security. So all these chains have their own isolated pools of security, and then when they want to interoperate with each other, they have to actually trust that the other chain is secure. And that might work when there's only like a handful of chains, like the Cosmos Hub and Osmosis and the other like major Cosmos projects. But as you start to get into this much longer tail, kind of much bigger, more diverse internet of blockchains, that's not going to work, because not every chain is going to be that secure. And so really, that will really hamper and limit the utility of this whole vision. So Celestia and a modular blockchain architecture solves those two problems, and will actually enable us to launch blockchains super easily without having to create a new consensus network from scratch, because that's like Celestia kind of acts as this universal consensus network that anyone can plug into. And on top of that, it provides this shared security. So rather than having to create your own pool of security on your own, you inherit security from Celestia, and you can connect with other blockchains securely because you kind of share this common base layer. So where Celestia fits in this, it's not competitive. It is providing a service. It's almost like like an app chain in a sense, but its application is just consensus and data availability for other chains to build and use and tap into. So that's where how Celestia fits into Cosmos.
I think also Ismail gave a very good talk about this last year at Cosmoverse. So people should definitely check that out. You can find it here on YouTube as well. But as you mentioned, shared security, interchain security is actually now just a month or two away to come on the Cosmos Hub. And the Cosmos Hub also being basically the most valuable blockchain in terms of market cap in the Cosmos ecosystem. That might be something that might make sense from your opinion, because you just said obviously if there's a small new blockchain, right, like it doesn't work as a shared security provider, but for the Cosmos Hub it might. So what is your views on that? And I don't know if you have looked into the idea of mesh security, what Sunny and Jake from Juno and the Confio team has been working on. But what is your thoughts on mesh security?
Yeah, also a great question. So there are a lot of, I think of all of these as different tools in the tool set for shared security that have different trade-offs. So when it comes to interchain security and consumer chains, I think this is a very valid path. However, it has like a lot of limitations. So first of all, it's not permissionless, right? Like you have to actually, if you want to launch your chain, it's like a governance proposal and it takes a lot of time. Whereas if you want to launch a blockchain on Celestia, it's permissionless. You just have to pay fees. So anyone can, at any time, it's like using Ethereum. You don't have to ask Ethereum to deploy a smart contract, right? It's a similar kind of thing. The other problem with interchain security in the long term is that it is not actually very scalable, because basically what's happening is you're taking the same set of node operators and then you're basically making them do more work. So it's more akin to like a block size increase, in that you're forcing node operators to do more and more work than it is like an actual like scaling a blockchain. Because ultimately, to scale a blockchain, you want to be able to do node operators do less work, but the amount of like throughput that you can handle. But of course, interchain security comes with a lot of other benefits. And so I'm not saying that one is universally better than the other necessarily. They're just different tool sets, and builders who have different preferences will choose different things. And then when it comes to what is it called? I'm blanking on the name.
Mesh security.
Mesh security. Right.
Yeah.
I really liked Sunny's presentation, and I especially liked his that he brought the chain link thing at Cosmoverse. That was hilarious.
Yeah.
I controversially. So I think mesh security has benefits, but I think it's a little bit oversold, frankly, in terms of its security. So basically, and this is kind of a more technical problem, but so the way the mesh security works is that one chain, takes stake and posts it on another chain, and this chain recognizes that stake and says, okay, I'm going to allow you to have voting power on this chain. But the issue is that that happens. That's coordinated by a set of smart contracts on both chains, and so. In typical proof of stake, slashing is very important, right? Because that's how you incentivize good behavior, or disincentivize bad behavior, I should say. And the issue is that there's a lot of slashing events that you cannot prove on chain, on a smart contract. So you are effectively creating this system where someone could stake on your chain and be voting and then do something malicious and you actually have no power to punish them because you cannot prove on the smart contract on the other chain that they did something wrong, because some of the things that you can do wrong just cannot be proven on chain. And so eventually it kind of filters back down to the same core problems that the modular blockchain architecture has been built to solve. So you're going to end up needing things like rollups. You're going to end up needing things like data availability in order to have a mesh security system that's actually secure. So at that point, you already have shared security without needing this like cross-chain staking thing. So that's my opinion on mesh security. I don't think that. I think it's an interesting idea and it should be built, and it might have some use cases, but I think it's going to be relatively limited in the long term.
So here's a fun question. What is the trade-off of the modular blockchain architecture, if there's any?
Interesting. The trade-offs are so from each. So let's say I want to just build a smart contract. It can be more complex if like all of a sudden I need to deploy a new rollup, and there is slightly more overhead, because deploying a rollup right now is not as easy as deploying a smart contract. Like right now, I could go to Ethereum and just pay the gas fees and have my application running on Ethereum. In a rollup context, it is a lot easier than launching your own blockchain from scratch, but it is not like smart contract level easy. You still have to operate some level of nodes. However, this is actually, and so I should have mentioned this earlier, but there's this, I would say, open problem that still needs to be solved in the modular blockchain stack, which is like rollup sequencing as a service. So like rollup node operating as a service. So that I, as a developer, could actually just write the software of my blockchain and then press a button, and someone will handle all the infrastructure of running the nodes. Like Celestia handles the consensus and data availability part, but who is actually running the nodes to ensure that rollup is functioning properly? And right now, there isn't really a solution for that. I would have to probably run those nodes myself or recruit a very small, maybe set of nodes to do it. So, but I think that's a problem that people will eventually solve. And interestingly, the mechanisms behind interchain staking and interchain security are, I think, will form a sort of basis for that, solving that problem. And so I actually wrote a post on our forum about how you could actually combine interchain security with sort of a modular blockchain architecture of Celestia and kind of get the best of both worlds, where you could solve this sequencing as a service problem. So that's kind of the way that I see that.
Okay, interesting. Yeah, and maybe can you also explain how that works and what's kind of like the difference between rollups and Appchains? Since you just mentioned the validator sequencing is an issue, like that doesn't seem to be an issue on Appchains, right? So how do they differentiate? I also saw the Friends Validator made an awesome thread about that. But maybe if you could, from your perspective, or I'm not sure if you've seen the thread, summarize it, and then some of the conclusions, like how they differentiate, and maybe what are some of the trade-offs and pros and cons between rollups and Appchains on a very high level. Yeah.
So recruiting nodes and validators, in a rollup, a sequencer is a validator. And they're kind of the same word, but you use a different thing because they're slightly different in terms of like a validator, you're actually running full consensus and doing all these things. In a sequencer, you're just executing the chain and posting your blocks. But anyway, an app chain builder actually faces the same problem, except at a bigger scale. And that, like, when you run an app chain, because you have to have a whole consensus network from scratch, you actually have to recruit a bunch of validators, and you have to also, as I said, issue a proof-of-stake token. So for a rollup operator, you don't have that, but you still do. There is some level of infrastructure. You need at least a handful of nodes that are running the sequencer, and also the decentralization and security threshold for those nodes is like significantly lower than like a full validator set. So you very much have that problem. I think that's one of the problems that Celestia solves for app chain developers, is that it really, really, really reduces the overhead for building and deploying your own app chain. So I just want to make that super clear. But the point was that if you're a smart contract dev right now, it is more overhead to deploy a rollup than it would be to deploy a smart contract. I expect that, like, one of the goals of Celestia is that we want to make it as easy to build a blockchain as it is to build a smart contract. So we're trying to build the tools and the different services that kind of like will bring that closer and closer together, so that, you know, it won't be, you know, if I'm a developer and I want to build some kind of Web3 application, I look at the different suite of options in front of me, and it's like the smart contract, you know, app specific rollup, and then like a full on app chain or just my own blockchain, whatever. We want to make these two almost the same amount of work, such that it's like, oh, well, it's kind of a no brainer. Maybe I'll just do an app rollup rather than a smart contract. But there's still a lot of work to be done to get there.
Can you explain the architecture of how Celestia is built? I mean, typically, like, you know, in Cosmos App Chain, it's built up using the Cosmos SDK. It implements IBC. It's running on Tendermint. Is that also, are some of these elements also in Celestia, or are you guys building everything from scratch? And what role does IBC play in Celestia?
Good question. So again, Celestia is very much part of the Cosmos ecosystem, in that we're also using Tendermint and the Cosmos SDK to build Celestia itself. So Celestia is kind of an app chain, right? And so, but we've modified Tendermint slightly. Obviously, like, Celestia is the first blockchain that has been built for specifically data availability. So we've had to do some modifications to Tendermint, but that, like, broadly, we are kind of like a Cosmos zone. You could think of that. And so we are IBC enabled and all of those things, and we are kind of like plugged into the broader ecosystem on that front. But the core thing that makes Celestia different than a typical blockchain is what we call, it's a new technology called data availability sampling. And so to take a step back, like one of the core issues around building this modular blockchain stack is that you need to have a very scalable and secure base layer. And so, like, but one of the problems, one of the age-old problems of blockchain scaling is that scaling block size or block space at the layer one is basically it's just very difficult. So, you know, back in the day, from the early days of Bitcoin, they were talking about, like, oh, well, what happens when we reach the 1 megabyte block size limit on Bitcoin? Are we going to increase the size? What are we going to do? And essentially, they decided not to, because increasing the size of the block will make it harder to verify the chain, which then makes it more centralized. So they opted not to do that for very good reasons. The same with Ethereum, right? Like, they have a certain gas limit. They won't go beyond that, because if you go beyond that, you compromise the whole value of the blockchain. So that is kind of, in a nutshell, like the core problem of blockchain scaling is, like, increasing the block size always leads to centralization. And that was the case until 2019, when Mustafa, one of the co-founders of Celestia, published a research paper co-authored with Vitalik called fraud and data availability proofs. And what it proposed was this model where you can actually increase the block size at the layer one without increasing centralization, without making it more expensive to verify. And the enabling technology there is data availability sampling. So we're the first blockchain to actually, on our testnet, you can spin up a light node and sample the data on the block. And what that does is it basically makes it so that, you know, you can have a certainty that the block data in Celestia has been published without actually downloading all the data. Because, as we talked about, in order to build these secure, transparent applications on blockchains, you need to make sure that the data behind it has been published. And typically, without data availability sampling, that means you have to download all the block data. But obviously, as the block gets bigger, that becomes more and more work, and more causes more and more centralization. So data availability sampling makes it so that you can do that, you can achieve that without actually doing more work. So you can have, you know, a gigabyte size block or something insane, and just the end users that wants to verify that only download, you know, a few hundred kilobytes or something to that degree.
What are some of the cool use cases that this unlocks, this technology, as it matures? And maybe you can also talk about some of the projects in the thread that friends made. They also mentioned Eclipse, which is using the Solana VM and also implements IBC. So they're basically connecting a lot of these technologies. So yeah, maybe talk about some of the use cases and some of the projects that are launching on Celestia.
Absolutely. So before we get too far into it, I would encourage people to look at our Modular Fellows program. So there was a blog post that we posted, and in there's a list of a bunch of different projects that are building on top of Celestia, and there's a huge range. So obviously you mentioned Eclipse. They're really exciting because, so one of the things that a modular blockchain stack does is it decouples sort of the execution from the underlying blockchain. So you can actually run any kind of execution environment on top of Celestia. You can run the EVM, you can run the Solana VM, you can run a Cosmos SDK app, you can run a Substrate app. Almost anything is possible. So the amazing thing about Eclipse is that they're taking the Solana VM, which is the second most adopted virtual machine in the blockchain space today after the EVM, and they're making it so that you can build a Solana VM based rollup. There are already a lot of EVM based rollups, right? Like, Arbitrum and Optimism and all those, the fabled ZK EVM, and then it's making it so that the Solana VM is going to take a similar path. So a developer can come to Celestia and say, "Hey, I want to build a Solana app chain," and they're going to have the tools to do that. Another use case that I think is really interesting is, and this is why one of the reasons why an application developer would build a rollup or an app chain versus like a smart contract, is MEV. So when you build an application as a smart contract, you end up leaking the MEV value to the underlying L1, and you might not want to do that because that's basically giving away free money. So if you build an app chain or an app specific rollup on Celestia, you're actually able to capture that MEV. So that's one of the things that we want to in the long term enable, is sort of like MEV modules in your sequencing software. So when you build a rollup on Celestia, you can actually find ways of capturing that and redistributing that MEV. And so projects like Skip are working on things like that, and we're really excited to explore those opportunities with them. I don't know. I assume you've probably had Skip on this show. If not, you absolutely should. Love those guys.
Yeah.
Oh, really? Okay. Wow. We got to make that happen. Well, yeah. Let me know if you're interested, because they're brilliant and building some super interesting stuff. They've built like MEV Tendermint, and they're live. They're going live on all these different Cosmos zones. So those are some of the big ones. There's a lot of people building. We also have something called the Quantum Gravity Bridge, which makes it that if you're building a rollup that settles to Ethereum, you can actually leverage Celestia for off-chain data availability. There's some projects like Constellation who are making it so that there's kind of like this EVM, out-of-the-box EVM rollup you can deploy that settles to Ethereum, but also uses Celestia. There are some really other interesting projects that are more in stealth, so I won't say their name, but they want to build like a ZK rollup version of like the Cosmos stack. So imagine in the long-term future, you could deploy like have kind of the equivalent of the Cosmos stack of like IBC and interchain standards, as well as like the Cosmos SDK, where you have all these different modules and you can really customize things. But it's all like ZK provable and all in the ZK rollup format, because in the long term, that like having a ZK rollup has just amazing scalability and interoperability properties. So like I do think that is kind of one of the end games. So I'll stop there. There's like, I could go on for a really, really long time.
Not, yeah. But it sounds like even on top of Celestia, like the goal is not to primarily have like end user facing applications, but it's more going to be like different VMs in combination with different consensuses and all these kind of things. So different blockchain ecosystems on top, and then on top of that, you will actually have, or within that, you will actually have a lot of applications for consumers and end users. And I guess from there on, it's just like an unlimited array of like applications. But that's really cool. Talking about the landscape, You also said earlier that you guys are currently in testnet. What is the roadmap now? I mean, what's the road to mainnet kind of, and yeah, what is also the utility in that context maybe for the Celestia coin? You will also have your native coin. So what are some of the utilities for that? And then yeah, well, maybe you can talk a little bit about timelines and launch.
Absolutely. Well, I just want to touch on what you said, which is that Celestia is a sort of a meta community, in the sense that, like, a meta ecosystem, I should say, because it's like this underlying infrastructure on which you can build so many different things, and it's almost like our customers are very much like application, or like I should say roll-up builders, or people who want to build their own blockchain. And so you're right, like the end user applications then are built on top of those things, but they're also going to be app specific chains. But yeah, so Celestia, the modular stack kind of changes everything. Like, the way that people have been building ecosystems and thinking about ecosystems is going to change dramatically over the next few years as modular blockchains become a thing. But in terms of our roadmap, so we have actually several testnets that are live. One is geared towards testing the actual data availability sampling and consensus and like the core protocol. The other is actually geared towards developers who want to build rollups. So I should also mention that we have this software called Rollmint, which helps you, or it's actually now it's called Rollkit, and it helps you build your own application-specific rollup, and it's compatible with the Cosmos SDK. So anyone who's listening wants to play around with that, like, we'd love to work with you. And we're going to be moving to an incentivized testnet in Q1 of next year. And so that's going to be really useful to bootstrap our validator ecosystem and to test certain aspects of the protocol. And then shortly thereafter, in Q2, likely, we will launch our mainnet. So yeah, we have a big year coming up next year. And hats off to all of our engineers who have just been doing insanely great work on all aspects of the protocol. And our proof-of-stake blockchain. So the token is used for staking, and it's also used to pay for transaction fees. So Celestia is in the business of selling block space. So you come to Celestia if you want to build a blockchain, you come to Celestia and you pay basically per byte of block space that you want to consume. And so that's kind of like in the same way that in Ethereum you pay for like per amount of gas that you use. And in Bitcoin, actually, it's the same. You pay per byte of block space you consume. But the difference is, one of the key differences is that those chains have a finite amount of block space that they can sell, right? Mm-hmm. And what that ends up being is you have this like point of where you fill up that block space, and then all of a sudden it becomes very, very expensive for people to use it. And so you kind of end up pushing users off to other platforms. Like, I think that's why there's so many EVM forks out there, is because of that problem. If people could have stayed on Ethereum and had lower fees, they would have. And so the interesting thing about a modular blockchain like Celestia is that there isn't a finite amount of block space. The block space can keep growing as there's more users, because it can scale with the number of nodes in the network. So we won't, hopefully, I mean, our goal is to make block space very, very cheap, so that people don't really think about fees. And then second of all, to keep it cheap in the long term, even as we scale and have like, millions in the future, billions of users on Web3, we want to make it so that like the cost stays the same. So you don't have that negative network effect where people are like, oh shit, now, Ethereum, it cost me $200 to, make a trade on Uniswap or something. So that's the long-term vision.
I really like that comparison to Bitcoin and Ethereum, because I think the block space debate has been going on obviously for many years in Bitcoin, and that's also why Bitcoin Cash exists, and all these Bitcoin forks. Same for Ethereum, like I said, plenty of EVM chains out there. But yeah, very interesting, and I'm excited to see when Celestia goes on mainnet, how many also of the Ethereum. I already see like a lot of Ethereum developers are really, really interested and bullish on what you guys are building. So yeah, it's going to be interesting to see how much also applications will migrate over to Celestia. But yeah, final question maybe. I see a lot of people are super excited working with you guys, for you guys. How big is your team currently? I think it's been growing a lot over the past months, no?
Yeah, well, we're actually a fairly lean team. We kind of believe that we'd rather hire fewer and higher quality people, because also, like, having been through this before with Harmony, like having I would say size of a team is sort of like a very bad vanity metric, because actually having more people often increases the amount of overhead and just coordination costs. And it's similar, actually. There's a lot of analogies with this to like actually running a blockchain. So in a typical blockchain, the more nodes you have, especially like for proof of stake, the more overhead you have, because there has to be more communication between all the different nodes. And so having a smaller set that can execute faster and is like higher powered is more effective. So we're currently around 40 people, mostly engineers, and we will definitely be scaling the team, but we're not in any kind of rush to like reach a certain head count. So, but yeah, you're right that the team is growing, and we're really lucky to have some extremely talented engineers on board who are just, some of the best in the space. And I think that's where we're really lucky, is that this is such an early technology, data availability sampling. No one's built it before. And we have in-house, I think, the world experts, both from theory and as well as like implementation. And we just plan to continue to grow that expertise.
Yeah, and 40 is a decent amount. If you say like they're all high quality developers, they know their stuff, they've been around for years. That's a decent amount. So yeah, really cool to see. Final question before I let you go. Actually, the community has asked me this a lot as well. What's up with SEFMOS? I think that was announced before FMOS went live. Is that still something that somebody's currently working on, or is that just kind of like an idea that will be picked up again once Celestia goes live and FMOS is more mature? Or what's the stand there?
Yeah, so SEVMOS is this idea of having a settlement layer that mimics what Ethereum would do. But rather than, so like the problem is if you have Celestia in Ethereum and you try to build a rollup that settles to Ethereum, but uses Celestia for data availability, you end up with this kind of like weird architecture with security trade-offs. I think a lot of people will build such rollups, but the idea of setting up of Celestia, that rollup could just live and only live on top of the Celestia ecosystem. And there's just a lot of better properties you get from that. And that's what SEVMOS, the vision for SEVMOS is. The project is actually still very much alive and well. And there will be, I think, more news about that forthcoming, probably early next year. And so stay tuned. It's very much alive and well. And I think will be a critical part of the Celestia ecosystem. It will be under a different name. And yeah, so stay tuned is what I'll say for that.
Nice. I like that. Cool, man. Yeah, I really appreciate that. Maybe if you, before you go, is there any final words from your side? Anything that you still want to share that we haven't touched upon? Yeah, then feel free to share that.
No, this has been an awesome interview as always. And as you can tell, like Celestia, we're just so passionate and excited about the Cosmos ecosystem, and always happy to we just want to support. And again, we really think that we can power, like supercharge the Appchain vision and the Internet of Blockchains vision of Cosmos. So yeah, we're lucky, and also again, we're so thankful for the Cosmos community for having contributed so many public goods, for contributed so much thought leadership and knowledge, without which Celestia would not exist. Like seriously, like we stand on the shoulders of giants, and I'm not just saying that. Like it's very, very much true. Like people like Jay, Ethan, Zucky, all these folks, like we all owe them so much, not just Celestia, but the entire blockchain space. And so and all the builders, obviously. And so yeah, we're just really grateful to be a part of all of this.
Yeah, I think that's a very cool way to end the interview. Also, I think from my side, it also shows like just how dynamic this space is. It's an evolution, right? And I think we always talk about like end games, but I think this is based on what we know today, right? Like who knows what's happening in 5 years? All these technologies are advancing so fast, and there's new discoveries, new research going on all the time. So exciting to see how that all develops. But yeah, we'll definitely have you on for part 4 at some time. So looking forward to that, and yeah, we'll keep in touch.